given the series, and they give us a formula here, does this series converge or diverge? And if it converges, find the sum. You can see the answer is it diverges here. Let's see how they found that out. So first off, this, remember, is a big Greek S. It stands for sum. So it's literally the S in the Greek alphabet. Capital S, sigma, it's the name, whatever. It kind of looks like it. It stands for sum. You see it, you want to think sum. I'm adding up something. And we start here at n equals 1, and we end at infinity. So let's crank out a couple of terms here. Let's plug in n equals 1 to this formula. So I get 4/3, plug in a 1 right there, to the 1 minus 1. And what is that? That's 4/3 to the 0. Anything to the 0 power is 1. Right? Remember that? Anything to the 0 power is 1. Now, plus, now let's plug in n equals 2. That plus comes from the fact that this is a sigma. We're summing up. We're adding up these terms. Now plug in a 2 right there for n. 2 minus 1. So that's going to be 4/3 to the first. Here, let me just bring this down. So this is 1 plus, and then 4/3 to the first, that's just 4/3. Okay. Let's go to 3 plus n equals 3. Well, that's going to be 4/3. Now we're going to plug in a 3 there to the 3 minus 1, which is 4/3 to the 2. If you square that, that's 16/9 on your calculator, plus ... This goes forever because, again, it ends at infinity. So this is an infinite series. And so the first thing we have to do is find out what's happening from term to term. What's going on from term to term? What's being added, subtracted, multiplied, or divided from term to term? You can always figure that out. The ratio, right? That's what R equals. It's the ratio of you take the second term and you divide it by the first term. So because the ratio, the common ratio, is any term divided by the previous term. So you can take the second term over the first term. So the second term, 4/3, over the first term, over 1. Well, that's easy. That's just 4/3, isn't it? Because anything divided by 1 is just itself. So our R equals 4/3. Divide that on your calculator, you get 1.333 forever. Now, what do we care about that? Well, this is an infinite geometric, right? The infinity, we're going to infinity. An infinite geometric series. What does it do? So this is important to know this. Number 1, if R is between -1 and +1, then it converges, which means it has a finite sum. Even though there's an infinite number of terms, they add up to a finite sum, and that sum equals A1 over 1 minus R. But you can only use this formula if R is between -1 and +1. If R is not between -1 and +1, then it diverges, which means it doesn't have a finite sum. It adds up, usually going to infinity. So, and that's our case, right? 1.333, that's not between -1 and +1. So that's why we say ours diverges. These numbers get too big. They're getting bigger and bigger. If you add up numbers that are getting bigger and bigger forever, you're going to infinity. You're not going to add up to a finite sum. So it diverges, and when they come down here for the sum, we just put D and E does not exist, is what we're saying there. The sum does not exist. It actually is infinity. So there's no number that exists that's the sum of adding all those up. Can't be done.